Welcome back to Caesar Education. In this video, we'll be discussing geometric sequences. We've already went through arithmetic sequences and quadratic sequences. In those two sequences, what we would do to determine what type of sequence we were dealing with, we would find the difference between the terms. And if the first difference was constant, we would conclude that the sequence that we are dealing with was an arithmetic sequence. But if the difference we were looking for, the second difference was constant and the first difference was not, we knew that we were dealing with quadratic sequences. Now with geometric sequences, let's try to find that difference and see which the first, the second, or the third will give us a constant value. Now to find the difference, we said that we take the following term, subtract it by the previous term, and then we find the difference. Now we continue the following term, subtract the previous term. So 16 subtract 8, it will give us 8. Now 8 subtract 4, it will give us 4. Now the first difference is not the same. So therefore it is not an arithmetic sequence. Let's find the second difference and see if the second difference is constant. Now the following term, subtract the previous term, 18 minus 8, it will give us 8, and 8 minus 4, it will give us 4. Now if the first difference is not constant and the second difference is not constant, then we are not dealing with the arithmetic sequence, we are not dealing with the quadratic sequence. But notice how the following sequences are just a repetition of the first sequence. We had 4, 8, 16. The difference also gives us 4, 8, 16. If we continue to have more terms, and we found out the difference here, we would find that this sequence will keep going on, repeating itself until infinity. So how do we identify a geometric sequence? So instead of finding the difference, we are going to find the ratio between the two terms. By ratio, we mean that we are going to take the following term and divide the previous term instead of subtracting the previous term. So instead of 8 minus 4, what we are going to do is find 8 divided by 4, which is 2. We're going to do that again with the following terms. The following term, divide the previous term, it will give us 2. The following term, 32, divided by the previous term, 16, it will give us 2. Now, we can see that the ratio between the terms is the same. So the ratio here is the same, 8 divided by 4, 2, 16 divided by 8, 2, 32 divided by 16 is also 2. This is how we identify a geometric sequence. When we look for the ratio of our terms, the ratio will be constant. Now, how do we find the next term in a geometric sequence if we do not have a difference? In arithmetic sequences and quadratic sequences, to find the difference, we would add that difference, that constant difference that we had. But with geometric sequence, to get the following term, we are going to multiply. So to go from a previous term to the following term, we take the previous term, multiply it by the ratio to get the following term. And that is the definition of a geometric sequence. It's a sequence whereby to get the following term of the sequence, we are going to multiply by a constant ratio that we call R. We are going to denote the ratio as R. Now, I'll repeat that again. A geometric sequence is a sequence whereby to get the next term of your sequence, we are going to multiply the previous term by a constant ratio called r. Therefore, to get 16, we must multiply by our constant ratio 2, which will give us 32. Now, to get that ratio, remember, you divide the following term, divide by the previous term, and we call that our ratio r. And we say that to get your ratio, you are going to take the following term and divide it by the previous term. You must remember that with arithmetic, we will use d and say it is our common difference. Here we are dealing with a common ratio. And we would get it by taking the following term and subtracting the previous term. Remember that the n represents the position of a term in a sequence. So if we take term 3, we will subtract it by term 2, because 3 minus 1 will be 2. And that's how we identify a geometric sequence. Now, let's take this following sequence here and see how we can find the ratio r and see if it will be constant. How do we do that now? We say that to find r, you must take the following term, divide the previous term. Now, if you take term 1, term 2, and term 3, if we take term 2, t2 over t2 minus 1, it gives you t2 over t1. I just did this so that you get reminded what the n minus 1 is, and I will not do that again. So t2 divided by t1 is negative 3x over negative 3. So this term is t2 and that is t1. And that will give you 3 divided by 3, our ratio between these two terms. Our ratio of these two terms is x. Now, we haven't concluded that it is a geometric sequence because we only have one ratio. Now, if we look at the following ratio between term 2 and term 3, and it also gives us x, then we can conclude that we are dealing with a geometric sequence. Let's do that right now. So r is also term 3 divided by term 2. Now term 3, we have it here. It is negative 3x squared over term 2, negative 3x. We divide those and you will get x. Now we know that we are dealing with a geometric sequence, and that is how we find the ratio in our geometric sequence. Remember that our ratio for geometric sequence will be constant throughout the sequence that you are dealing with. Now, just like the quadratic sequence and the arithmetic sequence, if we do not want to write out all the terms of the sequence to find a certain term in our sequence, let's say in this sequence we want to find term 15. Now, it will take us a while to keep multiplying by 2 until we get to position 15. And remember, position is denoted by this n. So to make our geometric sequence easy, we use the general formula for the nth term. So this general formula, it will be a formula that you find and use it for every geometric sequence. And then you will then substitute the ratio of that sequence so that you make it simpler for you. So how do we find that? Now, remember that term 1 of our sequences, we have been denoting it by the value a. Now, if the value term 1 is denoted by A, let's say we are talking about this term 1. Let's just write them all. Term 2, term 3, term 4. Now, if term 1 is denoted by A, what will be term 2? Let's go back to the definition of geometric sequences. A geometric sequence, it's a sequence whereby to find the following term of your sequence, you must multiply the previous term by a constant ratio called R. So to get term 2, we are going to take term 1, which is A, and multiply it by a constant ratio R, and that will give us AR. Now, even if we look at term 2 here, term 1 is our A, we multiply it by our constant ratio R, which is 2, so A times R, 4 times 2 is 8, and that is our AR. And following that same logic, what will be our term 3? Our term 3 will be the previous term, which is AR, multiplied by a constant ratio R. And remember that our R, to get it, we take the following term divided by the previous term. Always remember that and put it at the back of your head. So here we will have AR squared. Now, let's say here, our first term, you can see that, okay, we'll get to that. Cancel that. So, for term 4, keep following the same logic. We take the previous term, AR squared, and then we multiply it by a constant ratio R, and it will give us AR cubed. I guess that makes my point. So we can see that to get each following term and we multiply a constant ratio R, it follows a certain pattern, and it will always do that. Even with arithmetic and quadratic, we are always looking for a pattern. Now, in this pattern, we can see that for term 1, we have no R. So our R here is to the power 0, and everything to the power 0 is 1. So we have no R here, we only have A. Remember that this is not actually there. It's there, but we cannot see it. Yeah, believers will know what I'm talking about. So even with term 2, we have A times our constant ratio R, we get R, AR, and this R is now to the power 1. And then as we go down the terms, now it's AR to the power 2, and then AR to the power 3. If we look for term 5, we'll find that it will be AR to the power 4. Now, what is our pattern here? Our pattern is that for each term, the value of the term, it will be the first term times the ratio to the power 1 less than the term's position. So T4, our R will be R cubed. For T3, our R will be R squared instead of R cubed. R2, our R is R1. So it's always 1 less than the position. So here it's 2, the position is 3, which means even if we wanted to find term 5 and we didn't want to do all this, we will just know that since it's term 5, our R here will be 4, right? Now, let's write this in a general sense, as in like, for any term that we call the nth term, for Tn, any position on our sequence, we can say for T1, we will put 1 in position of the n and we will find a. Now, we always take for Tn, we always take the first term. The first term, you see, there's always the first term multiplied by the ratio, and that ratio, it's to the exponent of the position subtracted by 1. For position 4, this exponent is subtracted by 1. So 4 minus 1 is 3. So we'll always take n to the power r to the power n minus 1. So if we want position 3, we will have the first term a, r, and then 3 minus 1, it will give us 2. And that is exactly what we have here. Now, remember that this a is always the first term of your sequence. So if we were taking this sequence, our a will be number 4, the value 4, always the first term of your sequence. Let's actually take that sequence and find its general formula. And I'll just do it here quickly. Now, Tn, the nth term, the general formula of the nth term. Remember, that's how we pronounce, that's what this is called. It is called the general formula for the nth term. So if they say, what is the general formula for the nth term? What is the nth term? This is what they are looking for. They are looking for Tn. Now, for this sequence, the general formula for the nth term, it will be the first term a, which is 4. Our first term a, which is 4, and then our constant ratio r, which is 2. Let's put that in a bracket, which is 2 to the power n minus 1. N minus 1. Now, let's just check if we are correct here. Remember that this is our a, this is our r, and n minus 1. Our a is the first term of our sequence. R is the constant ratio that shows us that we are dealing with a geometric sequence. N, it will denote the position of the term on your sequence. Term number 3 will be n equal to 3. And Tn will be the term 4, 8, 16, the value of the actual term. So let's say we are looking for term 4 in that sequence. We will have 4 into 2, and then we substitute 4 in our n, which is 4 minus 1, and then we will have 4 into 2 to the power 3. 2 to the power 3, it's 8. 8 times 4 is 32. That's how you find the general formula of the nth term of a geometric sequence. Now, let's just take one more example so that we know that we have this on lock. Now, the first thing that you are going to do is find the ratio of your sequence. The ratio, we take the following term, subtract the previous term. So 5 divided by 10. 5 divided by 10 is equal to 1 over 2. We check it using other terms. So let's try with 2.5 divided by 5. That will also give you 1 over 2. 0.5. So you will know that, okay, the ratio is constant between the terms, so we are dealing with a geometric sequence. Now, what is the general formula for the nth term of this sequence? Remember that the general formula is given by Tn equal to AR n minus 1. So our Tn here will be A. What is A? The first term of the sequence, which is in this case the value 10. What is the ratio R of this sequence? We have found it here that our R is equal to 1/2. We checked it with different terms and found that it is constant. And if it's constant, then it's a geometric sequence. So our R here will be 1/2, and we have n minus 1. Now let's just find a term in our sequence. Let's find term number 3. Term number 3 and see if we get 2.5 to check if it worked. So term number 3 will be T3 equal to 10 into 1/2, 3 minus 1. That gives us 10 into 1/2 squared, which is 10 into 1/4. Now a quarter of 10 is 2.5. Just like we found it here. I went first there just to get the answer and prove it. We will not need to discuss the algebra of our sequence. Now they could ask you to find term 50. You'll just find T50 and substitute 50 here, 50 minus 1, and find your term. And that is the overview of the geometric sequence. I will make another video whereby we work with different examples so that we get a more clear understanding of geometric sequence. In the next video, we will discuss series, which is the sum of the terms in a sequence.